start by explaining this Q-sort algorithm I had some trouble with last time. So the mistake was that I had this as equal sign, and this should have been less or equal. I'll just quickly explain it. You don't have to try to type this again, okay? So if you had a list of numbers, say, import random, so import random, then there's a way to get random numbers, right? So let's make size 20. It's easier. Okay, so if I change the Q-sort code to actually print out the lower and the higher, so let's say print lower, comma, A0, comma, higher, and then run this. Let me make this larger. So if I quick sort A, here's what's happening. So very first time when it's run, you see that the element 79 was chosen, right? So 79 was chosen, and it split the list into two smaller subsets. This one and this one. Of course, 79 happens to be one of the higher numbers in this list, so the ones that are higher was less length than the lower one. Then what happened was that this lower one was fed back into the function. See, we're doing recursive idea here. So when it's fed back into the function, this lower one, again, the same idea, 39 gets picked up, and you divide the entire rest of the list into ones that are lower than the 39 and bigger than the 39. So you have these two other chunks. And then this one gets fed in again. And since 15 is the highest one, you don't have anything. I did not have this less or equal to, so I didn't have a separate if statement to handle when the length of the list is 0. See, there's nothing in here, right? In this case, since there's nothing to sort, you should have returned that A back again. But what happened was it still did this lower and then higher, which are both going to be empty lists, right? And those empty lists will be sent back again, and you just have endless call of itself, just like the turtles all the way down story. So we just get like function is calling itself over and over and over again, and it never stops. And guess what? Every time you call a function from one place, the computer has to know where to return the result to. So it has to return the address where the function was last called, and that address goes into something called a stack. It's a type of a memory which has a slightly different structure. Mechanically, it's just like every other memory, but the way that the computer handles the stack is a bit different. So things in the stack you just pile up, and the things that were last pushed into the stack gets read first. So it's like last in, first out kind of a thing. So that stack gets overflowed, and you get the stack overflow error if you do that. Okay? But now that I have this if statement to control the case when the length of A is 0, what happens is that this length 0 list will be just returned without being touched. So yeah, that's it. It just doesn't get touched. And then the other ones that are, like if it's length 1 or length 0, there is no more thing that you do with it. So that's what happens. So that's qsort. Okay, so what do I have in mind today? Well, I have two things. One is the Numpy package. So let's start with the Numpy package. I'll say Numpy basics. Now, when it comes to calculating large amount of data very fast, Python is not good at it because it's an interpreted language, right? But what if Python can call some other language that's not interpreted but it's compiled, meaning that everything in there is already translated to the machine language so that there is no separate interpretation step that's needed. And that's exactly what Numpy is. So let's import Numpy. Import Numpy as NP. And when you import Numpy, usually we import it as NP. There are several commands that come with it. It's a huge library, so if you want to see what's in there, you can do dir np as usual. So if you enter, this is a very big library, right? So many things, and it doesn't end here. So some of the commands in Numpy are very specialized to a subtype. So there's also something called Numpy linear algebra package. So if you do dir np.linalg, that's specifically for linear algebra, you end up with these other things. So it's like some of these are function names, some of these are some additional package names where you can go inside and get more. So it's quite a big package. So there's no way I can explain everything in here, but first you might notice something like sine function here. See, Python doesn't know sine of anything. So if you did sine of, say, 1 radians, if you ask that, and it's going to give you an error because it does not know what sine is. So what you need to do is now you can do either two things. You can do from Numpy import sine. Okay. Then you can ask what sine of 1 is. It'll give you the value of sine 1 radians. Or you can, since we already have the Numpy, you can write it like Numpy sine of 1. You get the same thing because these are the same functions. Okay. Now sometimes having this np dot is annoying, so even if you load up the Numpy package as np, you might still want to do it this way for some of the things for the code to look cleaner. That's something you can do. Now the most important thing about Numpy is that it has its own data structure called Numpy arrays. So let me show you an example. So if A is equal to Numpy array, and array can be built from any iterable. So let's say range of 10. So what it does is now A is equal to 0 through 9. Okay. On the other hand, if we do B as list of range 10, that also gives you some kind of a list of numbers from 0 through 9, right? So, of course, the types are different. If you did type of A, it's going to say it's a Numpy array, Numpy n-dimensional array, that's what it's called. Whereas if you look at what the type of B is, it'll say it's a list. Okay. But there is a big difference. I mean, they're very different. They're like different things. Okay, but let me first talk about similarities. The way you index it is quite similar. So if you do a of 0, it gives you the first element. If you do a of 5, it gives you the sixth element. The sixth element happens to be 5 here. And same thing with b. b of 0 will give you 0, and b of 5 will give you 5. So that's not anything different. And you can also index it similar to the list. So if you do a colon 3, do you remember what this does for lists? It gives you the first 3 items of the array. Okay? And same thing, b colon 3 gives you the first 3 items of the array, of the list. Yes? Okay. Okay, and you can also do a of -1 to fetch the last number of a, just like how we do it with the list. Right? So in this aspect, they're very similar. But the big difference would be, like, I think the similarity ends somewhere there. So there's a big difference. For example, if you say b of -1 is apple, Python won't complain. Now you have the last element replaced by apple. Whereas if you do a of -1 equals to apple, it's going to say no. So the problem with a is that a is storing only integers. So if you look at type of A0, you can see that it's a Numpy integer type with 32-bit lengths. So there are ways to express integers using bits. And if you use more bits, you can express bigger numbers. So if you have int 32, the largest number it can express is 2 to the 31 power minus 1. That's how large it can go. Of course, there are int 16 for a smaller one if you want to save memory. So it's a NumPy int 32. And the problem with NumPy array is that NumPy arrays can only have one single type for the entire thing. So if I do, say, a of -1 equals to 5.5, it will accept it, except that if you ask what is a, now you see that instead of storing 5.5, it stores 5. And the reason is, what happened was that 5.5 is fed into the int function, which will convert it into an integer. And if you take a float into integer, it basically acts as the floor function, which means it just gets rid of the decimal value and only takes the integer part of it. So that's why this happens. Okay? Now, if you want, you can redefine a as np.array of a, but now with d type instead of integer. You can put this as float. So if you do it this way, and then you ask what a is, you see that it's basically the same, but there's something different now. What's different? You see this dot here, right? And that dot means that these numbers are not integers. Internally, Python is storing them as float. Now, floats have different limitations. So if you ask what the type of A0 is now, you'll see that it is now NumPy 64-bit float. So you have more information stored for the same number 0 because this can potentially express other kinds of decimals. Okay, so the first difference between a list and an array I'm pointing out is that lists, you're allowed to have mix of different data types into the list, whereas for NumPy arrays, everything has to be the same. Now, if this is the case, you might ask like, oh, so array has more limitations. A list seems to be able to do more. Why do we bother using array, right? That would be the natural question. And it really has to do with the speed. As I said, NumPy is really a way for Python to call these all these packages written in C++. So since those things written in C++ are compiled things, when you call them, those get called in without any interpretation, so it's a lot faster. So to demonstrate that, let's try the following. Let's now make A as np.array of, say, this time range of, say, 1,000 numbers. Okay, so that's going to be a bigger array, right? And let's make B the same. B would be list of 1,000 numbers. Okay. And then we'll define two kinds of functions doubling this. So first of all, let me show you how to double a number. Oh, that's another problem with list and an array. So if you do, say, 2 times an array, say 1, 2, 3, 2 times a list, 2 times 1, 2, 3, it will just repeat the list twice. That's what it does, right? But if you do 2 times NumPy array of the 1, 2, 3, then it just doubles it, right? So, so the way that NumPy treats the data is like it's treating like a vector. So some of you may not have seen vectors yet because you haven't taken physics, but vectors are just like an array of numbers, but where you're allowed to multiply a number outside. That's called a scalar multiplication. And also you can do np.array of one thing, 1, 2, 3, to np.array of 3, 2, 1. If you add them, it just simply adds. That's called vector addition. So the arrays in Python are primarily vector objects. Whereas if you did the same thing as lists, it just does concatenation as we saw last time, right? Yeah, it just puts the two lists together. So that's the difference. Now let me demonstrate the speed of the NumPy by making the following code. So def double, we'll make a double of a list. Double of a list. And the way we do this would be to make a new list, L2, as an empty string. And you go through all the numbers in L and append L2 the twice of I. Okay, and then once you make the secondary list, you will return the L2. Okay, so now let's see how it works with double 1, 2, 3. It gives you 2, 4, 6, just like how this did. Okay. Now I'm going to look at the time that it takes to execute it in the Python way and time that it takes to execute in the NumPy way. So there's something called time it. If you do %time it, you can time something. So the way you use it is %time it, and usually you want to use some kind of a for loop to repeat something, and then you call that function. So suppose you do time it for I in range. Just doing it once doesn't take too long, so let's repeat this, say, 1,000 times. And I want the double function of B. Remember, B was a list of 1,000 items, right? So you're doubling 1,000 items, and then you're repeating that 1,000 times. So how long does that take? Quite a long time. Oh, maybe I have to decrease this. This is taking too long. All right, I think 1,000 was, oh, it did. Okay, so, oh, right. So what it does is sometimes if you just run it for once, it might take a longer time than usual depending on your environment. Maybe you have a browser open and it's doing something. Computers do many things in the background, so if you just run this once, then you can't really know for sure how long it takes. So it actually ran this thing 10 times, and then it did 7 times 10 runs. So this thing inside was repeated 70 times in total. And by doing that, it got a better measurement. It takes about 102 milliseconds. Now, if you do the same thing so let's put up arrow and double B, and then replace this to 2 times A, right, which will do the same kind of calculation, but notice that A is a Numpy array, and 2 times is the scalar multiplication vector for vectors. So if you do that, 2.2 milliseconds. So how much faster is it? 50 times faster. And that's the usual speed up that you would see if you write something in Python and you rewrite it in C++. So, long time ago, very long time ago, when Twitter was born, you know what Twitter is? Now it's called X. They used the language called Ruby on Rails to deploy it. Now, Ruby on Rails was an interpreted language. It was very easy to program. People loved it. But the problem was Twitter got big so fast. This idea of limiting your words to 140 characters somewhat struck a point to the millennials back then, and they really liked it. So everyone started using Twitter. And guess what? The Ruby on Rails could not handle it because it was interpreted. It wasn't fast enough to update things. So what they did was they had to rewrite everything into another code. Maybe it was Java. I don't remember exactly which one. But when they coded it again, then with like only a small increase in hardware, they could actually serve a lot more users with that. So things like that happen. You write a code in Python because it's easier to write, but then at some point you might have to speed it up very fast, so you write it again in C++. Now, but notice that we're still using Python and it's still getting 50 times speed up, right? And the reason is this code is not purely Python. This is really Python sending requests to a C++ code, which is already compiled, so that's why it's fast. So when somebody says, oh, you wrote this in Python, just rewrite it in C++, it'll be 40 times faster, 50 times faster. Well, sometimes it's true if you're really writing everything from scratch in Python, just like what was the function that we made? Yeah, this function, just like this function. But in many cases, when you use Python, you end up using some packages that's really calling C functions. That's true for a lot of the machine learning packages, like TensorFlow. If you're using a lot of machine learning in your code and what you're doing is really calling TensorFlow packages from your Python, then even if you change everything to C++, you won't see that much speed up. It will be slightly faster because still you're taking time to call the functions and it's coming back and forth, but it won't be like 30 times faster or anything. Okay. All right. So so that's really some basics of ND array. Now another aspect of Python array is that you can have multi-dimensional array. That's what n-dimensional array means. So let me show you how that works. You can do let's just redefine A. A is np.array of array of arrays. So let's say 0, 1. So it's a small array of 0 and 1. And then you have -1, comma 0. So that's A. Oh, I should have put a dot somewhere because I want this to be decimals. So if you put a dot somewhere, then Python will see this thing and say, oh, okay, I'll just make everything float. So if you look at what A is, you can see that everything now has a dot. So it's a float. B equals to np.array. Let's say 3, comma 4 dot. Okay. So we have two arrays. If you look at a.shape, notice that a.shape is not a function, it's an internal variable. So it says 2, 2, meaning that A has 2 elements, right? These, but each element is an array of size 2. Okay. On the other hand, if you ask what B is, B.shape, and it'll say it says 2 because it's just an array of length 2. As I said before, you can add vectors, but because these two are different sizes, you can't add them. However, you can do multi-dimensional indexing. So if you do A colon, comma 0, what happens? It takes the first column. Oh, by the way, some of you may have seen matrices in pre-calculus. Some of you may have not. If you took Calculus 3, we also, in this school, we also teach matrices. But anyways, this thing is called a matrix because it's a two-dimensional array. It's an array inside an array. That's called the matrix. And going this way is called a row. And if you go vertically, that's called a column. So what happened is that if I did A colon 0, it fetched the first item of each element, okay? And that way we got the first column. To get the first row, you would do A 0, comma, colon, and that will give you the first row. Okay? So that way you can get slices of arrays. And slices of arrays don't create new variables. It's a view, meaning that it doesn't take up extra memory space when you use slices. And both of these are both size 2, so it's perfectly okay to have a slice and add to B. It will do it. And because we're adding 0, 1, 2, 3, 4, the vector addition is just element-wise addition, so we get 3, 5. And remember, the point is that this is done with lightning speed compared to what Python speed would do. Okay. Now, if you also have learned matrix multiplication, this can do matrix multiplication by something called at operator. So if you can do A at B, this creates 4, comma, -3, and this matrix happens to be something called a 90 degrees rotation clockwise. So what it did was it took this 3, 4 vector, point 3, 4, and rotated it 90 degrees clockwise with respect to the origin of the plane. So if you plot this 3, 4 on the plane and rotate 90 degrees clockwise, the new point you're going to get will be this one. So if you never have learned what matrices do, it can do many things. Basically, if you're a STEM major, there's no way of getting around matrices. You will have to learn it. You will be using it a lot. For some gamers here, You should appreciate matrices because, as I just showed you, it can do rotations, right? It can do three-dimensional rotations. So some of you gamers here had to beg your parents to buy these expensive graphic cards, right? How many GTX 40 something series users here? Just one? Okay. RTX, right? RTX 3000 series. Anyone? 2000 series? One? Okay. Okay. 1000 series. Anyone? I have a 1070. Yeah, I bought it like a long time ago. But anyways, if you ever wondered what your graphic card is doing when you play these games like Valorant, it's basically doing matrix multiplication, because anytime you turn your head around and to see where the enemy is, the entire background has to rotate, right? And all kinds of rotations are computed at the same time with blazing speed by your graphic card. That's how your graphic card manages to show you these beautiful graphics. That's all matrices, okay? So matrices are very important, and in Python, that's handled by Numpy. Okay, so maybe some other things I should tell you is you can also reshape the given matrix. So it's a 2x2 matrix, 2x2 array, and we can flatten it by asking it to do 4 comma. It's a weird, maybe just 4 is okay. Reshape 4. Then it returns the array with, this time it's not a multi-dimensional, it's not a 2-dimensional array, it's a single-dimensional array with length 4. So sometimes this is needed, especially when you do machine learning later on. What else is there? Oh, there's something called like np.zeros, which is an easy way of creating a matrix. Sometimes when you have to store some things into a matrix. Oh, see, arrays are fixed in size, so you can't do append. So sometimes when you want to take data and store it into an array, you can't do append just like the list does. Instead, what you have to do is you have to make an empty array of zeros first. So let's say we have a 5 by 3 by 2 array. Let's see, is this how I do it? Yeah, okay. So this is a 3-dimensional array where you have 5 items, and each of the 5 items are 3 by 2 arrays, 3 by 2 two-dimensional arrays. Okay, so that's what zeros does. A similar one is sometimes you need an array of ones, so you can do numpy of ones. So you get this. And you can do numpy of sign applied to this. And what you should realize is that most of the Python numpy functions take in not just a single number, but it also will be able to take these arrays. And what it does is it calculates the sign of every element in this array in a vectorized form, which means instead of having a for loop to go through every element, which will be slow, it's just calling the numpy package in a special way so that it's very fast. Okay. All right. So that will be the intro to numpy. Now let me go to the second stage of today's lecture. Okay. So I want everyone to go to edabit.com, edabit.com. Okay, so The website is edabit.com. So go to that website and okay, what is Edabit? Edabit is like a bunch of coding challenges. There are several languages here. If you look at it, you can do coding problems in C#, C++, Java, JavaScript, PHP. We will be using Python, so please select Python. And I found the very easy one to be too easy, so we'll do some easy ones here. Okay, and it has a bunch of problems that you can do. Now, such a thing is sometimes called Leetcode. So, Leetcode. So, Leet is the geeky way of saying elites. So, if you're a lead, that means like you're a programmer who's very capable. You're an elite programmer, okay? And at some point there was this Leetcode, meaning that you have all these coding challenges and you do them to prove that you know how to code. And then it became part of these interview processes. So if you ever go seek a job, and programming is somewhat involved. So for example, if you want to work in Wall Street and you're trying to become a quant or some kind of a finance manager, where you're expected to write some code to analyze the market and stuff, they would ask you to do some Leetcode in front of them. So they give you some simple questions. Can you code this in Python? And you have to code it in front of them. So if you want to get a good job, you would want to practice Leetcode. And, you know, several college students nowadays in the elite schools, they would actually spend their time doing Leetcode outside of their regular school work. So while they're taking classes in school, they do the homework and do all that, but in addition, they will devote extra time to do some Leetcode. So by the time when they're seeking jobs, they can say, hey, I can do this job because I can code in Python or Java or whatever. And if the job does require coding, they're going to ask, like, can you code this? And you have to code in front of them. And they will do excellently, and they will get the job. Okay. All right, so we're just getting a very basic taste of Leetcode. Let's see. So are you guys all registered? Ready? Okay, so let's do this. Python easy. Click that. Now, do you see the same thing that I'm seeing? Stuttering function as the very first one? Yes or no? Or do you see something? Okay, so let's just go with the very beginning. Let's start with the stuttering function. Let's see what it does. Okay, so write a function that stutters a word as if someone is struggling to read it. Okay, the first two letters are repeated twice with an ellipsis and space after each. Then the word is pronounced with the question mark question. Okay, so if you do a stutter of incredible, it's going to give you back in incredible. Okay. Now you can now go to the code, and it says to make this stuttering function. But since trying to do it over here is a bit scary, let's just go back to the instructions and think about this incredible. So let's go back to IPython and see how we can do this. So if your S, the string is incredible. Okay, first, how do you get the first two letters? Do you remember? S, and then colon 2, right? That's going to give you the first two letters. Right? That's what we have, yes?
0 starts at 0.
You could also do 0, 2. If you just do colon 2, that's same as 0, 2. Same thing.
No, I mean, like, I thought it counted like 0, 1, 2, so you do colon.
Oh, but if you do list of range of 2, it stops at 1. So in Python, if you ask to do something until some number, it stops it right before it. So yeah, so you're right. If you think that this produces 0, 1, 2, then it should be giving you 3 letters. But in Python, the practice is that always when you talk about a terminating point, the actual numbers stop right before that so that it's easier to see. This is less confusing. That's just the Pythonic way of doing things. Any other questions? Okay, so now how would you attach a ... to this first 2 letters? How do you do in and then ... Come on, this is easy. You should know. You just put it there, right? How? Do you just do it this way? Is this okay? The answer is no. If you do it that way, it's going to say no. So how do you do it? Yeah. Put a plus, right? Because plus for strings is a concatenation operator, right? Plus has different meanings for different data types. So if it's a list concatenation. If it's a string, it just concatenates strings. If these are numbers, you just simply add. It's a usual addition. So if you do that, you get in. Okay. Now if I want a space, then this is what I'll do. Okay, so now let's go back. We have incredible. How do I make it to be in ... space, in ... space, and then incredible question mark? S colon 2 plus ... space, right? And then what's next? Plus what? S2, right? Plus ... space, right? And then plus the original word, right? What is that? S plus question mark, right? Awesome. We made it. Well, actually, we haven't made it yet. We have to make this as a function. So let's define it. Right? So df stutter s. Okay. What should this return? It should return exactly this, right? So all I'm going to do is I'm going to copy this and put return open parenthesis. By the way, you don't have to open a parenthesis, but I come from other languages as well, and it's less confusing for me to put parentheses all the time. So it's my habit of putting parentheses. Okay, so I'm going to return this. Let's see, stutter, incredible. Good, good. Great. Okay. Okay. Wonderful. Okay. So it works well, right? So we are almost done. Now we just copy this, define stutter. We'll just copy it and paste it over there. And we're done. Let's check. Checking. Test passed for all kinds of things. And submit final. And what does that get me? I think the problem is, yeah, I got 10 points. So I had an extra 5 points to begin with. Okay. So I would say this was easy. Okay. All right. Oh, just a minute. Okay. can't go there. So the code I had was this define stutter. Yeah, so if yours is not working, maybe you put some extra spaces somewhere. Maybe you put some space after question mark or something.
It says error name string integer is not defined.
Oh, because the original code has this as word. Sorry. So in the original code in the edit starts with this as word. So if that's the case, then you should rename this as word because you're returning that word. So this will be another way to solve the same thing. Actually, this is better because if you just see this, it's hard to make sense of what this is doing. But if you read this, you can see that you're taking this word and taking the first two letters. So variable naming is very important. I'm only making these very short codes in this class, so I'm not making a big deal out of naming, but if you're ever in a bigger project, then naming your variables properly is very important because at some point you have to read your code, and if you don't name it properly, you end up with big problems, okay? Okay, did you manage to run it now? No, still? Okay. Well, I'll try to help you afterwards. Okay. All right, so let's look at the next one. Find the discount. Let's click this one. Okay, create a function that takes two arguments, the original price and the discount percentage as integers, and return the final price after the discount. So if there was a designer bag that's $1,500 and it's 50% off, as usual. All the designer bags, they say they're really expensive, and they also come with tremendous discounts, right? So 50% off of $1,500 will be $750. Here's another thing, $89. If you do 20% off, you get 71.2. That's the idea. So you get two numbers. Okay, you get the idea? All right. Let's go to the code. So this time, let's try to respect this. But before we do this, let's talk about how we can do the calculation. So if I have price equals to, say, $100, and discount is 20%, then what is the actual price you end up paying? Simple math, right? What's 20% discount of $100? $80, right? Okay, so we have to subtract, but this is too easy. Let's say we have this time price as 50. Okay, then how do we calculate the final price? Well, we would have to calculate how much price is off, right? So that is calculated by taking 20% of $50, right? How do you calculate 20% of $50? Oh, multiply by 0.2, right? So price off will be 0.2 times 50, right? And then the final price would be price minus the price off. So you get $40. So that's your answer. However, what we did is not kosher because we hand typed in 0.2. Where did we get this 0.2 from? From 20, right? So how do you convert 20 to 0.2? Divide by 100, right? So we see that to be kosher, we should really have been saying discount divided by 100, and just for safety, let's put them surrounded by parentheses so nothing funky happens. So if we do discount by 100 divided by 100, you get the 0.2 and then times 50. And then if you do the same calculation, that's good. Okay. So that's going to be our algorithms. If the price is given, we calculate the price off by this formula right here, and then finally just return the price minus price off. Okay, now we are going to write this as a code. So let's see, let's copy this one here. Copy, let's paste it. Okay, def dis price comma discount. We're just going to do exactly how we did it before. We'll even just copy and paste it. So price off will be discount divided by 100 times 50. Oh, not 50. Oh, this shouldn't be 50. What is this? It should be the price, right? So price off will be discount divided by 100 times the price. Okay, and then what do you return? Return price minus price off. And if I do discount of 120%, that's going to be 80. That's good. How about 50? Gives you $40. That's good. What if you have a $150 item and 50% is discounted? What's the answer? It'll be half off, right? What's half of 150? 75. So you get 75. Good, good. And then it will even be able to calculate things that it won't be very easy to think. Like what's, if your price is say $73 and you have 30% off, what is it? Oh, okay, so it's $51.10. That's what you see. Okay, so I think this is the correct one. So let's copy this, paste it over everything. Let's delete everything and then just Control V. I pasted it, and then we will check. Should work. No, what's wrong? Oh, failed. So there's a floating point error here. Sometimes this calculation will give you 0.2699, and it doesn't equal to 231.27. Okay. So in such a case, what you need is something like a floor function. So let's see. So let's try to recreate how that could happen. So if you have like 37%, that's okay. What happens if I do it this way? Oh, this seems to be fine over here. That one's causing float point error. Well, I know what to do. I'm just trying to think about how best to explain this. I don't think there's a floor function. Yeah, that's not given. There's a math function called floor. You can do import math and then floor, or math.round, I think, round. No? It only has floor? Okay, so floor of x as an integer. This is the largest integer. Okay, something like that. But you know what? Here's another way to think about it. And frankly, I don't know how to explain this. That's see, if you do this, you get $10 because right now our discount is 20. Let's put discount as 37 and price as 713, just like how we did before. Then if you do this calculation, you get 263.81. Oh, because that's price off. Okay, so this much is being subtracted, right? And what we could do is to hold off on dividing by 100. So what we could do is not divide by 100. Delete that one. Okay? And we just subtract from price times 100 minus this thing. Then what happens is that this answer should have been 449.19, just like what we have here. But instead, because I have everything multiplied by 100, it's 100 times bigger. But what I think is that if you do it this way, then when you divide this calculation by 100, it's not going to cause a problem. So that's what I think. So let's just, so that's a problem with the weird way that Python does this. Or maybe all I need to do is not do it here and then divide by 100 here. Maybe this could be let's check if this helps. No, still the same error. So what we're going to do is we're going to multiply by 100 first, subtract the price off, and then divide by 100. Yeah, now test passed. So so this is something weird. You know, in everyday calculation, A times B times C is same as A times C times B, right? So for any floats, you would expect that this should be true, but in some cases this is no longer true because of these weird floating point errors. Floating point errors happen because the way Python tries to store real numbers, it can't remember all the decimals, so it has some weird way of saving these floating, and you end up with some problems there. Okay, so let's submit final. Okay, good.